If you have ever stood outside on a clear night, tilted your head back, and felt something cold crawl through your chest, not from the wind, but from the sheer wordless weight of all that darkness between the stars, then what I'm about to say is for you. If you have ever caught yourself staring at the sky and thinking quietly, a little uncomfortably, where is everybody? Then stay right here, because that question is not a casual one. That question might be the most important question our species has ever stumbled into, and the silence that answers it is not peaceful. It is terrifying in a way that most people never let themselves fully feel. Here's the thing. Nobody warns you about when you start asking serious questions about the universe. The universe does not owe you a comfortable answer. It does not hand you a reassuring brochure. It just sits there, enormous and indifferent and staggeringly old, and it dares you to figure it out. And somewhere in all that silence, in all those hundreds of billions of galaxies, each packed with hundreds of billions of stars, with planets orbiting most of them with the raw ingredients of chemistry scattered absolutely everywhere, somewhere in all of that, the math says there should be others. Civilization signals something, and yet nothing, complete howling silence. If you leave this conversation now, that silence stays meaningless noise. But if you stay, you're going to walk away with something genuinely rare. The mental tools to think about this clearly, the way a physicist actually thinks, without the Hollywood mythology, without the comfortable lies, and without losing your mind in the process. What you're about to understand changes how you see every single night sky for the rest of your life. So do not go anywhere just yet. Imagine a Tuesday in October, not a dramatic one, just an ordinary Tuesday, the kind where dinner has already been cleared and the dishes are soaking in the Someone, let us call him a father of two, walks outside onto the back porch of a house in New Mexico, coffee in hand, just to get a moment of quiet. The kids are arguing about something inside, the TV is on, and this man, completely unremarkably, tips his head back and looks up. The sky over New Mexico is genuinely magnificent. No city glow to wash it out, just stars, layer after layer of them. The soft smear of the Milky Way cutting diagonally across the whole thing like someone spilled cream across black velvet. And this ordinary father, who is not an astronomer, who fixes heating systems for a living, just stands there, and something shifts, because he suddenly feels viscerally, physically in his stomach how small he is, not in a poetic way, in a genuinely unsettling way. Like the ground under his feet just became a little less solid. That feeling has a name in physics. It does not have a romantic name. It is called confronting the scale of the observable universe, and it hits people differently depending on how far they let themselves actually go with it. Most of us flinch away. We look back at the warm yellow light in the kitchen window. We hear the kids bickering, and we let the feeling dissolve back into ordinary life. We are very good at that. Humans are extraordinary at shrinking the universe back down to the size of their immediate concerns. But here's what makes this moment worth examining. That feeling, that specific gut punch of smallness under a starry sky, that is not weakness. That is the beginning of real thinking. That is the first room in a very large building that most people walk past their entire lives without ever opening the door. And right now, together, we are going to open it. Not to scare you, though it might a little, but because on the other side of that door is something genuinely beautiful and genuinely useful and genuinely yours if you are willing to walk through. Now, if you're finding this line of thinking uncomfortably large, if you're sitting with that peculiar mixture of fascination and low-grade dread that good cosmology tends to produce, do something interesting with that feeling right now. Drop a comment below. Tell us, when you look at the night sky, do you feel wonder or do you feel fear? Because that distinction matters enormously, and we are going to come back to it. And while you're at it, if questions like this one genuinely light something up in you, the kind of questions that do not have easy answers, that have the nerve to stay open and uncomfortable, then subscribing to this channel is one of the better decisions you can make today. There are more of these conversations coming, and you're going to want to be there for them. Now back to the silence. The Fermi paradox, as it is called, is one of those ideas that sounds deceptively simple and then quietly dismantles your assumptions like a patient and thorough carpenter. Enrico Fermi, brilliant Italian physicist, sitting at lunch at Los Alamos in 1950, having a perfectly casual conversation about flying saucers with his colleagues. And then mid-conversation, apparently out of nowhere, he asks, "But where is everybody?" And everyone at the table immediately understood exactly what he meant, which is itself remarkable. They did not need him to elaborate. The question landed fully formed. If the universe is this old, if it is this large, if the conditions for life appear to be this common, then where are all the civilizations that should have had billions of years head start on us? Where are their signals? Where are their probes? Where is any trace of them at all? And here's where it gets genuinely uncomfortable, not in a fun way. In a "this might actually matter" way. The observable universe is approximately 93 billion light-years across. It is about 13.8 billion years old. Our own galaxy, the Milky Way, contains something in the neighborhood of 200 billion to 400 billion stars. Recent estimates from the Kepler Space Telescope data suggest that the majority of those stars host planets. The majority, not some, most. And among those planets, a significant fraction sit in what astronomers call the habitable zone, the range of distances from their star where liquid water can exist on a surface. Water which is not some exotic ingredient. Water which is absolutely everywhere in the universe. Carbon, the backbone of organic chemistry, is the fourth most abundant element in the observable cosmos. The math does not whisper that life should exist elsewhere. The math shouts it. The math practically grabs you by the collar and insists. So why the silence? Why has no signal ever arrived that we could confirm? Why, in all our decades of pointing radio telescopes at the sky, has nothing unambiguous come back? You could say, well, space is very big and signals fade. True. You could say, we have only been listening for a few decades with equipment that would look primitive to us in a century. Also true. You could say, maybe they are there and we just cannot recognize the signal. Reasonable. But here's the part that those comfortable explanations quietly skip over. And this is the part that deserves your full attention right now. Because this is where the building we have been walking through reveals a hidden basement, and the basement is not empty. There is a concept in astrobiology and existential risk research called the Great Filter. It was articulated with real clarity by economist Robin Hanson in 1998, and it is one of those ideas that, once you truly understand it, changes the emotional texture of looking at the night sky forever. The Great Filter is the idea that somewhere along the path from dead chemistry to starfaring civilization, there is a step or a series of steps so brutally difficult that almost nothing makes it through, a filter, a barrier. Something that stops the overwhelming majority of would-be civilizations before they ever get to the point where we would detect them. Now, here's the question that makes this idea so unsettling. Where is the filter? Is it behind us or ahead of us? If the filter is behind us, if the hardest step was something in our distant past, say the original emergence of life from chemistry, or the leap from simple cells to complex ones, or the evolution of something like a brain capable of abstract thought, then we are the lucky ones. We made it through. The galaxy is quiet because the filter is a rear-view mirror for us, and we are the extraordinarily rare survivors. That is a story with a somewhat hopeful ending, or at least a survivable one. But, and here's the cold part, if the filter is ahead of us, if it is something that civilizations encounter after they reach our stage of development, something like the invention of weapons capable of self-annihilation, or the collapse of ecosystems they depend on, or some failure of collective intelligence that causes them to destroy themselves just when they are on the threshold of becoming something lasting, then the silence of the universe is not a story about how rare life is. It is a warning, it is a graveyard, and we are currently standing in it not knowing whether we are walking toward the same wall that everything else walked into. Fíjate bien, that is not a comfortable thought, and it is not meant to be. The reason to sit with the discomfort rather than flinching away from it is precisely because the discomfort points towards something real, something actionable. A civilization that cannot face this question honestly is a civilization that has already started failing the test. What does it mean to fail the test? It means becoming comfortable with not knowing. It means choosing reassuring stories over difficult evidence. It means allowing the critical thinking infrastructure of a society, the science, the honest journalism, the philosophy, The willingness to say, I was wrong and here's new data, to erode slowly until the building is all facade and no foundation. And look at that building from the outside. A beautiful front, painted windows, but walk through the door and there's nothing holding the walls up. This is not a metaphor used lightly. This is what civilizational fragility actually looks like. Not a dramatic explosion, not an alien attack. A quiet, gradual, perfectly voluntary surrender of the tools that make understanding possible. And once those tools are gone, once genuine curiosity is replaced by performed certainty, once questions become threatening rather than energizing, the building does not fall dramatically. It just slowly stops being a building at all. Now let us go somewhere even more specific, because the physics here is fascinating and it tends to get glossed over in favor of the more emotionally satisfying Hollywood version of this question. Let us actually talk about why not even an advanced civilization, one that has survived its own great filter, one that has been around for 1,000,000 years longer than us, could simply show up here. Because this is where the universe reveals something genuinely strange about its own architecture, and it is something that requires us to rethink some very deep assumptions. The speed of light is approximately 299,792 kilometers per second. That sounds fast. It is fast. Nothing with mass can reach it. Nothing. This is not an engineering limitation that sufficiently advanced technology can overcome. This is a law baked into the structure of space-time itself, and it was one of the great intellectual achievements of the 20th century to understand why. Einstein did not just measure a speed limit. He showed why the speed of light had to be a universal constant, why the geometry of space and time themselves demanded it. And what that means for interstellar travel is genuinely sobering. Our nearest stellar neighbor, Proxima Centauri, is 4.2 light-years away. A light-year is the distance light travels in 1 year, moving at that tremendous speed every single second. At the fastest any human-built object has ever traveled, the Voyager probes, moving at roughly 17 kilometers per second, it would take approximately 75,000 years to reach Proxima Centauri. 75,000 years? Our entire recorded human civilization is roughly 5,000 years old. We are talking about a journey 15 times the length of everything we consider human history, just to reach the closest star. And Proxima Centauri is, on the cosmic scale, essentially our next-door neighbor. The galaxy is 100,000 light-years across. Now, advanced civilizations might do better than Voyager, much better. Perhaps they develop propulsion systems that can achieve a few percent of the speed of light. Perhaps even 10 or 20%. That is still centuries of travel time to reach nearby stars. And here's the deeper problem that even the most optimistic physics cannot easily dissolve. Relativity tells us that as you accelerate toward the speed of light, the energy required does not increase linearly, it increases exponentially. Getting to 90% of light speed requires vastly more energy than getting to 50%. Getting to 99% requires staggeringly more than 90%. Getting to 99.9% is, with any known physics, a project that dwarfs the total energy output of stars. The universe is not being coy about this, it is being explicit. And there's another wall in this building, a locked attic that cosmology opened for us in the late 1990s and which has not stopped being strange since. The universe is expanding, not just expanding, accelerating. The space between galaxy clusters is stretching, and it is stretching faster and faster due to something we call dark energy, which is one of those magnificently honest scientific names because it essentially means we know something is there doing this, but we have absolutely no idea what it is. The consequence of this accelerating expansion is that the most distant regions of the universe are right now receding from us faster than light. Not because they are moving through space faster than light, but because the space between us and them is growing so rapidly that the effective recession velocity exceeds the speed of light. Those regions are permanently beyond our reach. And that region of permanent inaccessibility is growing over time. The observable universe, the sphere of space from which light has had time to reach us since the Big Bang, is not the whole universe. It is our cosmic horizon. And civilizations beyond that horizon cannot reach us by any means. Not because they lack technology, but because the universe itself in its expansion has placed them outside of any possible causal contact with us forever. Bueno, so we have a galaxy that is immense, a speed limit that is absolute, energy requirements that are astronomical, and an expanding universe that is actively shrinking the fraction of it we could ever interact with. Even for a civilization a million years older than ours, the physics of getting here is not a solved engineering problem. It is a set of constraints written into the fabric of reality itself. The universe is not a place that rewards the assumption of easy travel. And yet, there's something even more fascinating hiding under all of this, because here's the question that does not get asked nearly often enough. What if they sent something other than themselves? What if the signal we are looking for is not a spaceship, and not even a radio wave in the conventional sense, but something we have not yet had the imagination to look for? This is where thinking like a physicist becomes genuinely liberating rather than limiting. A physicist, when confronted with a problem that seems impossible under current assumptions, does not simply give up. A physicist asks, which of my assumptions is wrong? And there are a lot of assumptions buried in the way we search for extraterrestrial intelligence. We assume they would use radio waves. Because we use radio waves, we assume they would announce themselves in ways recognizable to us, because that is how we would do it. We assume their timescales, their motivations, their definitions of communication would overlap with ours in some useful way. But consider this. A civilization that has been technologically active for 1 million years has had 1 million years to change, to evolve, to potentially become something so different from what we currently are that looking for their signals using our current instruments is a little bit like a medieval scholar looking for a smartphone by searching through manuscripts. The gap in cognitive and technological sophistication between us and such a civilization might be larger than the gap between us and a single-celled organism. And a single-celled organism is not going to find a smartphone by searching the pond it lives in. This is not a counsel of It is an invitation to expand the imagination. And it is also a reminder of something that a certain brilliant physicist from Queens, New York, used to say in various ways throughout his remarkable life. The first principle is that you must not fool yourself, and you are the easiest person to fool. We fool ourselves constantly about what we expect the universe to look like. We project our own cultural moment, our own technology, our own fears and hopes onto something genuinely alien and genuinely indifferent. And then we are surprised when our projections do not match what we find. Myra, there's a real discovery worth examining here, because concrete history makes these ideas tangible in a way that pure abstraction does not. In 1977, an astronomer named Jerry Eman, working as a volunteer researcher at the Big Ear Radio Telescope at Ohio State University, was scanning through printed data from the telescope when he saw something that made him write a single word in the margin of the printout. The signal had the exact characteristics that scientists had theorized a signal of extraterrestrial intelligent origin might have. It appeared to come from the direction of the Sagittarius constellation. It lasted the full 72 seconds that the telescope could observe a fixed point in the sky as Earth rotated, and its intensity followed the precise bell curve pattern expected from a point source in deep space. Eman circled it and wrote, "Wow, that printout," with that one handwritten word in red pen in the margin, became one of the most famous documents in the history of astronomy. The WOW signal has never been explained. It has never been repeated. Dozens of follow-up observations, some with far more powerful equipment, have found nothing. It sits in the archive of unexplained astronomical events like a door that opened once and then closed, and nobody knows what was on the other side. Was it aliens? Almost certainly not, based on current evidence. But here's what matters about that story. That moment in 1977, that red pen, that circled sequence of numbers and letters on a printout from a modest radio telescope, represents something precious. It represents the specific texture of genuine scientific inquiry. Not the grand announcement, not the confirmed discovery, the honest, uncertain, "This is something I cannot explain, and I'm going to be truthful about that moment." That is what science actually looks like from the inside. Not certainty delivered from a podium. Uncertainty carefully documented, honestly reported, left open for the next generation of minds to investigate. And here's the rehook that this story carries inside it. because the question it raises is one we cannot yet answer. If the universe is this vast, if the physics of travel is this prohibitive, and if even a signal as distinctive as the wow signal can slip away without confirmation, what is the actual probability that we have already been contacted and simply did not recognize it? What if the filter is not a future catastrophe but a present blindness? Let us go deeper into the architecture of the problem. Because there is a room in this building that most conversations about Fermi never enter, and it is the most interesting room of all. It is the room where physics meets philosophy and where the question stops being purely about aliens and starts being about us. Here's what we actually know about life. We have exactly one example of it, one Earth. Everything we think we know about life in the universe is extrapolated from a sample size of 1. In statistics, a sample size of 1 is not a sample, it is an anecdote. And building a theory of the universe's biological richness on a single anecdote is exactly as reliable as you would expect it to be, which is to say, not very. We do not actually know if the emergence of life from chemistry is common or stupendously rare. We do not know if the evolution of complex multicellular life from simple cells is routine or miraculous. We do not know if consciousness, the particular kind of organized information processing that asks questions about the universe, is an inevitable outcome of complexity or a bizarre accident that happened once on one wet rock orbiting one ordinary star. We do not know these things, and the appropriate response to not knowing something is not to pick the answer that makes you feel better and commit to it. The appropriate response is to design experiments, gather evidence, and hold the question open with intellectual honesty. Which is, by the way, one of the hardest things a mind can do, holding a question open, not resolving it prematurely into a comfortable story. Sitting with the uncertainty and continuing to think carefully within it. That is not a weakness. That is one of the most sophisticated cognitive capacities our species has developed, and it is in genuine danger of being lost in cultures that reward performed certainty over honest investigation. And this is where the existential urgency comes back, not as abstract philosophy, but as a practical concern for people alive right now. The same cognitive tools that allow us to think seriously about the Fermi paradox, about the great filter, about our place in the cosmos, are the same tools required to address every other serious challenge our civilization currently faces. The capacity for evidence-based reasoning, the willingness to update beliefs in response to data, the humility to say, this is what we know and this is what we do not know, and the intellectual courage to distinguish between the two honestly. These are not separate skills for separate domains. They are the same skill applied to different problems. A civilization that loses this skill, that becomes collectively incapable of honest inquiry because comfortable certainty is more emotionally rewarding, has not just lost the ability to find alien. It has lost the ability to solve its own problems. It has lost the ability to navigate the genuinely dangerous challenges that come with having the kind of technology we are building right now. And that is precisely the kind of soft, gradual, almost invisible failure mode that the Great Filter hypothesis warns us about. The filter does not have to be a single dramatic event. It could be a drift, a slow replacement of genuine curiosity with tribal certainty, a gradual preference for questions that confirm what we already believe over questions that genuinely threaten our assumptions. And the insidious thing about this kind of drift is that it feels fine from the inside. It feels like clarity. It feels like conviction. It feels like having answers. And all the while, the foundation of the building is quietly dissolving. Now here's where the conversation turns, because we have walked through some dark rooms in this building and it would be intellectually dishonest to stop there. Because the same physics that makes interstellar travel extraordinarily difficult, the same laws that produce the Fermi paradox, the same cosmic scale that makes us feel insignificant on a back porch in New Mexico on a Tuesday in October, that same reality also contains something remarkable. It contains us. It contains minds that can model it, investigate it, argue about it, and genuinely understand pieces of it. That is not nothing. That is, in fact, extraordinary. Think about what it means to understand the speed of light. Not just to know the number, to understand why it must be what it is. to follow the logic of special relativity through its geometric heart and come out the other side with genuine comprehension. There's a particular kind of pleasure in that, a pleasure that is worth naming because it does not get named enough. It is the pleasure of reality making sense of the universe which owes you nothing, consenting for a moment to be understood, and it is available to anyone willing to do the work of genuine curiosity. Here are the actual mental tools. The ones that work, the ones that a physicist actually uses when confronting the genuinely enormous, for thinking clearly about the cosmos without either collapsing into despair or retreating into comfortable mythology. The first tool is scale calibration. When the universe's size becomes abstract, bring it back to ratios you can feel. The observable universe is roughly 93 billion light-years across. The Milky Way is roughly 100,000 light-years across. That means the Milky Way is roughly 1/930,000th of the diameter of the observable universe. The solar system is roughly 1 light-year across when you include the outer Oort cloud. That means our solar system is roughly 1/100,000th the diameter of our galaxy. And Earth is roughly 12,700 kilometers in diameter. Work through these ratios slowly, let them land. Then notice that your brain sitting in your skull, which is sitting on Earth, just successfully modeled all of those scales. The universe is big. Your comprehension is real. Both things are true simultaneously, and holding them together is more honest than discarding either. The second tool is comfortable uncertainty. Science is not a collection of answers. It is a methodology for generating better questions. The most interesting scientists in history were not the ones with the most confident answers. They were the ones with the most productive uncertainties. Feynman himself said with characteristic directness that he would rather have questions that cannot be answered than answers that cannot be questioned. When you encounter something you do not understand, the scientific move is not to grab the nearest comfortable explanation. It is to name the uncertainty precisely, to articulate exactly what you do not know, and to treat that gap as an invitation rather than a threat. The third tool is what you might call proportional humility, not the paralyzing kind of humility that says we are so small nothing matters. That is a misuse of scale. Proportional humility says, given what we currently know, given the sample size we are working with, given the limitations of our instruments and our cognitive architecture, here's what we can say with confidence, and here's where we should hold our conclusions lightly. It is the difference between a scientist and an ideologue. The scientist knows the difference between the map and the territory and respects it. The ideologue confuses them and defends the map against the territory. The fourth tool is what physicists call the view from nowhere, or more accurately, the view from everywhere. When you're solving a problem in physics, one of the most powerful moves is to consider the problem from a reference frame that is not yours. Einstein built special relativity largely by asking, what does this look like to someone moving at a different speed? What does the same event look like from a different vantage point? Applied to the Fermi paradox, what does the universe look like from the perspective of a civilization 1,000,000 years older? What questions do they ask? What do they consider elementary? What do they have access to that we cannot currently conceive? This is not science fiction. This is a legitimate epistemic tool. Perspective taking at scale improves your models. It inoculates you against the assumption that your current moment is the measure of all things. The fifth tool, and perhaps the most personally sustaining one, is what might be called the long game orientation. The universe is 13.8 billion years old. Our species, Homo sapiens in its current form, has existed for roughly 300,000 years. The project of organized scientific inquiry is about 500 years old. The project of modern cosmology is about 100 years old. We are extraordinarily early in this investigation. We are, cosmically speaking, just getting started. The questions we are asking right now, about life in the universe, about the nature of dark energy, about the relationship between quantum mechanics and gravity, these are not questions we should expect to have answered yet. We are the first generation to even know what the questions are with any precision, and that is not a reason for despair. That is a reason for the particular excitement that comes with being genuinely early, with having more genuine unknowns ahead than behind, with being part of the first chapter rather than the last. And here's the thing about that. The thing that brings us back to the back porch in New Mexico and the father with the coffee and the stars overhead, that feeling he had, that cold, unsettling sense of scale, that is not a problem to be solved. That is a signal to be read. It is the universe getting your attention. It is the cosmos which has been arranging matter and energy for 13.8 billion years, producing a configuration of atoms that can look back at it and feel something about what they see. The fact that the scale is terrifying is not a bug. It is the appropriate response to accurate information about where you are. And once you have the tools to hold that accurate information without being destroyed by it, something interesting happens. The terror does not disappear, but it transforms. It becomes something more like awe. And awe is not a passive emotion. Awe is motivating. Awe generates curiosity. Curiosity generates questions. Questions, carefully and honestly pursued, generate understanding. And understanding, however partial and provisional, is how a species earns its place in a universe it did not ask to be born into. Now, there is a third loop that has been quietly open this whole time, and it is time to walk into it because it is the most personal one. We have been talking about civilizations, about physics, about cosmic scales, but all of that abstract machinery has a very concrete landing point. It lands on you, specifically on you. Right now, in whatever room you're sitting in, with whatever device you're using to receive this conversation. Because the question of whether humanity survives its own great filter is not a question that gets answered in a boardroom or a laboratory or a policy chamber, though all of those matter. It gets answered in the aggregate of individual choices about how to think, about what to value, about whether to treat curiosity as a luxury or as a survival tool. Every time a person chooses to sit with a difficult question rather than dismiss it, every time someone updates a belief because new evidence demands it, every time a mind refuses the comfortable myth in favor of the uncomfortable reality, something small but genuine happens. The culture of honest inquiry gets a little stronger. The foundations of the building get a little more solid, and the probability, whatever it is, that this species makes it through whatever filter lies ahead shifts just slightly in the direction of making it. That sounds grandiose. It is not meant to, it is meant to be precise. Culture is made of individual choices accumulated over time. The choice is to read carefully, to think honestly, to ask the questions that do not have easy answers. These are not separate from the large-scale question of civilizational survival. They are the substrate from which that survival is either built or neglected, and here's the final thought, the one that closes all the rooms we have walked through tonight, because it is both scientifically honest and, if you let it land properly, genuinely moving. We do not know if we are alone. We do not know if the filter is behind us or ahead of us. We do not know what the wow signal was. We do not know whether consciousness is common or rare in the cosmos. We do not know whether the silence of the universe is a graveyard or simply a gap in our hearing. We genuinely, honestly, with all the tools of modern science and all the accumulated intelligence of our species, do not know. And that is magnificent. It is magnificent because it means the investigation is real. It means the questions are live. It means there's something actual at stake when you choose to think carefully rather than casually. Something at stake when you choose wonder over and curiosity. Something at stake when you look up at a clear October sky and let the scale of it hit you fully rather than retreating back into the warm kitchen. The investigation of our place in the cosmos is not a hobby for people with too much time. It is the longest and most important project our species has ever undertaken. It started the first time a human looked up and wondered. It continues every time someone refuses to stop asking. The universe is not going to send a welcome message. It is not going to make it easy. It built itself according to laws that do not care about our comfort, and it placed us far enough from everything else that getting to the answers is going to require the best of what we are capable of. Not just the best of our technology, the best of our minds, the best of our willingness to stay uncomfortable and curious and honest in the face of the genuinely unknown. That father in New Mexico eventually went back inside. The kids had stopped arguing. The coffee had gone cold. He rinsed the mug and went to bed. But something had shifted, quietly and permanently, in the architecture of how he thought about where he was. The stars were still there after he closed the door. They will be there tomorrow night. They will be there long after every person alive today is gone. And somewhere among them or nowhere among them, there may or may not be minds doing the same thing. Looking out, wondering, asking where everybody is. The silence continues. The question remains open, and the fact that you are still here, still listening, still thinking is itself a kind of answer. Not the final one, not even close to the final one, but a real one, and for now, in this particular Tuesday evening in the long history of whatever the universe is doing, that is enough to keep going.